Everyone. My name is Asha and I am here with my teammates Pallavi, Lavanya and Kritika. Today we are going to present on the topic that plays very important role in machine learning. The topic name is overfitting and underfitting. These are the contents we are going to follow on this presentation. In machine learning, the goal is to build the model that can learn patterns from the data and make accurate prediction on new data. However, one of the biggest challenges is finding the right balance between the simple and complex data. Understanding these concepts helps us to design models that are accurate, reliable, and generalize well to real-world situations. It performs poor or both training and testing data and learns important relationships. Next part will be continued by Pallavi.
Good morning, everyone. I am Pallavi. Today, I am going to explain about data selection, choosing a regression model. For this practical task, we are require a data set suitable for demonstrating regression concept and the effects of model complexity. Recommended data sets: how house house price prediction, California housing prices, auto MPG dataset. Next. Implement polynomial regression. Degree to low complexity, the model cannot capture the curve of the data leads to high bias and low variance. And degree 10 high complexity model captures noise and fluctuations instead of the true pattern, leads to how low bias and high variance. Degree 5 balanced complexity capture the main data trend without fitting noise, balance bias and variance for better generalization. Thank you. Next slide will be continued by Kritika.
Thank you, Pallavi. Myself, Kritika from AML department. I would like to discuss about evaluation and analysis, and in that diagnosis bias versus variance. In machine learning, biases and variance help us understanding model performance. Underfitting degree 2. The model is too simple to capture the underlying pattern in data. As a result, it performs poorly on both training and validation sets, showing high bias and low variance. Next, overfitting. Degree 10. The model is too simple and learns not only the data pattern but also the noises. It performs very well on training data but poorly on validation data, showing low bias and high variance. Optimal trade-off. Degree 5. The model achieves a good balance on both training and validation. Errors are low and close to each other. It generalizes well to new data, showing an ideal bias variance trade-off. Next slide. Regularization technique. In that regression uses square weight as a penalty to shrink coefficient, controls variance and prevents overfitting. Next, lasso regression uses absolute weight as a penalty, removes less important features, simplifying the models. Third, elastic net mixes both L1 and L2 methods, provides balance between ridge stability and lasso future selection. Next, continued by Lavanya.
Thank you, Kritika. I am explaining the code. It has import libraries NumPy, Matlib, and Scikit modules. It has dataset creation and preparation, generation 80 random x values between 0 and 5. Target variable is the data will be split into 80% training and 20% validation. With standardization, improve numerical stability, especially for high degree polynomial features. Third one, polynomial regression for degrees 2, 5, and 10. Loop through polynomial degrees. What happens here? For each degree, polynomial features are generated. Example for degree 2 and for degree 10, it has 1 x square. Linear regression fits these explained features. Then the MSE are computed. It means average square difference between true and predicted values. The printed results are print f degree, train, and MSE. Next, the interpretation. Low degree it has 2. Model is too simple underfitting. High degree as 10. Model fits training data perfectly but performs worse on validation overfitting. Next, the plot training versus validation error. This plot shows the training error decreases as polynomial degree increases. Validation error first decreases then increases. Next, what happens here that lasso regression adds L1 and L2 penalty. The summary of this code is underfitting. It has a low degree polynomial can't capture data complicity. Next, the overfitting high degree polynomial fits noise well. Next, the regularization and train versus validation MSC. Here the conclusion, overfitting and underfitting are common issues in machine learning. It is too simple to capture data patterns while overfitting happens when a model is too complex and fits noise. The goal is to balance model complexity to achieve good generalization using techniques like regression, cross-validation, and proper model selection. This is our assignment. Thank you for giving this opportunity.